So a very warm welcome from Cambridge. My name is Liz.
And I'm Charlie.
We're members of the NRICH team. It's fantastic to have you all with us this afternoon. We'd like to say a big thank you to Trinity College here in Cambridge who fund these webinars so that they're free to you, and we do appreciate that. So some of you may be joining us for the second, or if not, high or multiple time, as it were. Perhaps your school is a problem-solving school. Perhaps you're joining as an individual teacher. You're all very, very welcome. What I'm going to do is I'm going to share the NRICH website so that hopefully you'll be able to see it on the screen, and then we'll get going properly. All right, so I'm hoping that you can see the homepage of the NRICH site. What we're going to do is we're going to go, first of all, to the primary teacher homepage, which, as primary practitioners, is probably a good place for you to mark as as your landing page, if you like. If you've been using NRICH for a while, you may well have noticed that we restructured ourselves just over a year ago, and we're now organising our tasks so that you can find them directly through the curriculum content that they're linked to. So that's the box on the left. You can find them according to the mathematical thinking skill that they aim to help you develop, or according to the positive attitude or the mindset that we feel could be nurtured through those tasks. Now, if you've joined us on previous webinars, you'll be aware of the fact that we've recently been focusing on our developing mathematical thinking strands. If I click on here just very briefly to show you, we've got 5 mathematical thinking strands to reflect the progression as you might work through a problem. If you click on any of those pages, you're taken to the guidance that we've written and some linked tasks. But what we're moving on to now is to think more about our mathematical mindsets, or the positive attitudes. And what better place to start than being curious? So if I click on being curious, what you've got right at the very top of this page is a link to the guidance that we've created, all about helping you to support your learners in developing their curiosity, nurturing their curiosity. Now, what we intend to do today, we hope, is inspire you, make you curious, in the hope that you can take the problems back to do the same with your learners. Now, we're going to have a sort of a whistle-stop tour through about half a dozen problems, we hope, in the time available. And in each case, we'll sort of we'll have a go at the maths all together, and then we'll give you a little commentary about how we think that task nurtures curiosity. Charlie, is there anything you'd like to add before we get going on our first task?
Okay, just a couple of things. So Liz talked about mathematical mindsets, or we sometimes talk about positive attitudes and so on. We're going to focus on curiosity today. In future webinars, we'll be thinking about being collaborative, being resourceful, being resilient. Those are the 4 attitudes that we think are important.
Yeah.
And when it comes to curiosity, I suppose there are a couple of things that occur to me. One is that we're used to telling students or pupils that giving the impression that to be a good mathematician, you need to be good at answering questions. I suppose today is about how important it is to be good at asking questions.
Absolutely.
That actually a lot of mathematical activity arises from the questions that we ask. So actually being curious is an important starting point, is a springboard to working mathematically. So that's one reason why we started with this. And the other one is more of a cultural thing. We're used to recommending to our friends books that we've been reading and that we're really enjoying reading, or films that we've been to see and recommending it. Liz and I have got colleagues and friends who sometimes ask us about, oh, have you got any good maths problems? Or, oh, you've just been to a conference and talked to teachers. Have you come back with any good maths problems? Or let me share the problem that I'm working on. It'd be really nice to have a culture in this country or abroad, where we share good mathematical problems in the same way that we share good books and films and songs and things of that sort.
But what better place to start than your classroom?
Absolutely.
Yeah.
And sometimes, for those of you who joined our last webinar, which was about working on problems outside school with parents and neighbours, and the attitude about actually maths can be an enjoyable thing to be doing outside the classroom as well.
Absolutely, absolutely. Thank you, Charlie. So the tasks that we're going to have a look at today, although we've deliberately chosen them because they particularly, nurture that curiosity, they are all linked to the curriculum as well. So you can be sure that the tasks that we're going to work on will develop children's understanding of mathematical ideas at the same time. So we're going to go back to the primary teacher landing page. So we're going to access all these problems through the curriculum linked box. And I'm going to click here on this link, which is the primary curriculum mapping document map. So what we've got here, if you've not seen it before, are all the objectives from the primary mathematics curriculum, and we've linked in NRICH tasks. So Charlie, to start with, I'd like to introduce you to a problem that's in this part of the mapping document in number and place value, and it's one that's suitable for quite young learners. And I'm going to scroll down a little bit into this section here, and it's called 8ness of 8. So let's click on this. There we go. And what we're going to do is we're going to watch the video all together to start with. It's a silent video, so there is no noise. Please don't be alarmed if you can't hear anything. Let's watch it together. Just have a little think about what you see, as we're watching. Okay, so now what I'm going to do is let's have a think about what we've just seen. In the classroom, I would spend a lot longer encouraging the children to talk to each other, but given our time constraints, we're going to leap in here. Charlie, when we created this video, what we didn't do was create sort of a story to go alongside it. And I'd like you, I'm gonna invite you, we're gonna watch it again, and I'd like you to create, if you like, perhaps what the caption might be, or imagine there was a speech bubble as we go through. So I'm going to play again. Hang on, let me just pause it to give you a moment. I'll play it again, and I'd like you, if you could please, to give me a little commentary as we go along. As you're participating, you might like to imagine what you would say if I'd invited you to do this. All right, Charlie.
So it's not clear how many dots I have yet, but now I can see 5 plus 3, 1 plus 1 plus 1 plus 1 plus 1 plus 1. This is 4 twos, or 2 plus 2 plus 2 plus 2, 3 plus 2 plus 3. This could be either 4 twos or 2 fours. This is sort of 8.
Hang on, I might just go back to that one. I'll pause that one a little bit. That one was trickier, wasn't it?
Yes, I'm all of a sudden thinking about angles and symmetry and apart from the very first image,
yes,
which was the 5 plus 3,
yes,
you had all the ones which sort of is symmetrical,
right.
and then you had 4 twos which could have been arranged in quite a symmetrical way. 3 plus 2 plus 3 was definitely symmetrical, either vertically or horizontal. 4 twos or 2 fours also. This has got lots of...
There's a nice, sorry to interrupt you, there are nice suggestions on the chat here. Compass points is a nice one. Lisa's saying she can subitize a group of 5 or fewer or less. Yeah, so subitizing is when we know immediately how many there are without having to count. Flower petal, nice.
Which is why initially it wasn't clear there were 8, but as soon as it was split up.
But the muddled heap made it hard.
Yes.
Yeah. Okay, I'm going to carry on. Let's go to the end, Charlie.
So 2 4s,
Mhm.
and again 2 4s or 4 2s. I think this is really nice because that's.
Let's pause that one. Yeah, that is nice, isn't it?
So it's either I'm thinking of it as 9 minus 1.
Oh, nice.
Or I might even think of it as, because I'm wearing my secondary school teacher's hat,
Yeah.
I might want students to think about it as 3 squared minus 1 squared.
Yeah. Oh, yes. Look, we've got a group at Halberton there.
But yes, it could be also 3 plus 2 plus 3. So it's
and
still symmetrical. So
lovely. Should we carry on?
But I do like the idea of challenging students to make mathematical sense of each. So you've got an image. What would be the mathematical way of describing what's going on?
Right. Okay. I don't think no, we're at the end. So we're back to the beginning. Okay. So what I might do now in the classroom is think about, right, well, if I gave you 12 counters, could you create your own, what could we say, your own storyboard might be a nice way of thinking about it, your own narrative about the number 12. So I'm just going to stop sharing the web page, and instead I'm going to share the video. We've got 12, the camera, we've got 12 counters here, but I'm going to invite, so Charlie, I think what we'll do is we'll invite participants to suggest,
to give me instructions.
To give you instructions. Oh, look, our
so that was my fault.
Has come a bit skew with.
So we're doing it the other way around. We're starting with the statements.
And you're going to try and create them.
Okay.
Yeah? All right. So, we've got one already.
And
Go on, sorry.
I'm not sure you quite agree with this, but I like the idea of, well, no, maybe also having a subset, which ones can be created, which are symmetrical.
Yeah.
Yes. Will it always? Yeah. Okay.
That could be an added challenge.
Yes.
Or an added constraint.
I will try. Tell you what.
Go on.
Whenever I get given instructions, I will try and create something that looks symmetrical.
All right. So we'll see if it's always possible.
And I'll see whether it's always possible.
Okay. So we've got a number of suggestions. Thank you. Your suggestions have been flooding in already. We have got,
I saw a 3 plus 3 plus 3.
3 plus 3 plus 3.
And I've organized it in a symmetrical way. And of course I could do it. Nice. I could do it this way or that way.
Very nice.
But actually, I could do it in any. It doesn't have to be horizontal.
It doesn't have to be horizontal or vertical, no.
Okay.
So is there a different way? So another suggestion is 3 times 4.
Okay.
Could you do anything different, Charlie?
I'm going to stick to trying to do something symmetrical.
Okay.
And I mean, I could spread them out a bit more, but I think that's exactly
all right. Let's see if we've got any other. What about 6 times 2? We've had a suggestion from Anila.
This is quite nice because I can take half of this, put it there, and now if I move that around, I've got 6 2s.
Nice.
Or 2 6s.
Nice.
And I do, yes. What did we go? 6. Okay, good.
Very nice. What else have we got? We've got a 1 line of 12 or 1 times 12. Somebody has written.
Okay, and again, that's going to be symmetrical. If I just do 1 straight line of 12,
yeah,
I can organize this. Okay, this is not the tidiest. Can we get rid of the participants, please?
Yes.
Thank you. Okay.
There we go.
But you know
just about all on the screen.
Okay.
Yeah. Okay, fantastic. What other suggestions have we had in? Right. So Paul says 12 seats on a minibus, 1 on one side of the aisle with pairs on the other in 4 rows. Does that make sense to you, Charlie? Shall I read that again?
Yes, please.
So we're imagining a minibus, seats on a minibus.
Yes.
So 1 on one side of the aisle with pairs on the other side of the aisle, 4 rows like that. I have this amazing urge to take over the counters, but I'm going to try. No. I'm going to try and resist.
No, go for it.
Okay. I think what Peter is suggesting is something like this.
Okay, so it's going to have a horizontal line of symmetry. And the slight advantage of bringing them all together is I got horizontal and vertical. So I've been trying to maximize the symmetry, but yes, this will keep the horizontal symmetry.
Yeah.
but it
will lose the vertical.
But
now here's a
yes.
challenge for us, Charlie.
Yes.
4 squared, take away 2 squared. Did you want any different coloured counters?
No.
No?
Because if this works,
Ooh.
so I've got 4 squared is 16.
Yeah.
Oh, yeah. Well, okay. I can do this, can't I?
Yeah, you can do it. Yeah.
Minus 2 squared.
That is lovely, isn't it?
Is also 12.
Mm-hmm.
And it's beautifully symmetrical.
Beautifully symmetrical. We've got a 1 + 5 + 5 + 1 suggestion.
So, so yes, I can have 5 and 5 and 5, and I can put my 1s there, and I've got something symmetrical.
Very nice. Okay, let's just do one more. 3 squared + 3. Is there anything you can do with that, Charlie?
Yes, I think I can. 3 squared + 3 will give me, I can do that.
Yeah, nice.
I was also wondering about,
Mm-hmm.
complements. So 1 + 11. I want students to know to be, because presumably you can do this with quite young children.
Yes, yes.
So I want students to know that 12 is 1 + 11.
Mm-hmm.
So if I put this count on top of the 6th one, I'm going to be okay.
Mm-hmm.
But it's also 2 + 10.
Mm-hmm.
And if I put 4 counters there and 4 counters there, I'm okay.
Still got some symmetry, yeah.
And if I do this, I can have 9 + 3.
Mm-hmm.
I can break it up, and I'm always going to be able to do something symmetrical, it seems. I can take this one out and put it there, and I've got 8 + 4. I can take this one and put it there, and I've got 7 + 5. Yeah. I wasn't really expecting this to happen.
How that's kind of.
But I can
what
take
happens now?
either. Well, that happens.
Very nice.
And then I take this one, put it there.
And then I end up going the other way
up.
I
go there and there, and I'm doing some things rather unexpectedly.
Yeah, how lovely.
I mean, we had planned most of what we're going to do, but
that we hadn't thought would come up.
We hadn't. I wasn't expecting this to happen.
Yeah.
And then we go
Very
back
lovely.
to there, and then we're back to doing things like this. And I think I can do it quite quickly. And I've stopped checking, and I'm reasonably confident every time we're getting something symmetrical.
I think we can safely say that this task has certainly piqued Charlie's curiosity. I think we don't need to go any further than that. I hope you can see. But Charlie, in terms of the curiosity aspect of this task, I guess we're so we're hooking children in with the 8 video. I might just stop sharing now, actually. Sorry. We're hooking children in with 8.
But we're also, Liz.
Yeah.
You sort of gave the impression, or you could give the impression, you'd done the video and you just hadn't got round to doing the captions or having the voiceover and silly me, I should have thought about it. And you're saying to the students, I need some help with this. I can imagine the students being really keen to help you out on this and what would be the caption, and then create their own storyboards with images and the captions, and then have that on display.
It'll be lovely.
And you can have a display of all sorts of different things. I can imagine students being, how many different, can
I create one that somebody else hasn't created?
Yeah, you've sort of stopped me.
I'm sorry. I'm sorry. I'm aware of the time. Absolutely, Peter. Great for exploratory talk as well. Yeah, absolutely. So there we go. That's our first example. Very, very accessible mathematics. But as Charlie has demonstrated, it will hook all ages in. So what I'd like to do is I'm going to go back to the NRICH site, and we're going to go back to the mapping document. And we'll choose a different problem this time to explore. So back to the primary teacher landing page, back to the curriculum map, which is here. And this time I'm going to take you to the multiplication, division and ratio tab, which is the 3rd one along. And if I just scroll down here, we're going to go to right to the end of the document. And this time we're going to look at a task that we suggest for year 2. By that, the starting point I would suggest is year 2, but we're going to show you how we could take it further than that. So this is a problem called lots of lollies. Charlie, I'm going to, rather than read the problem out, I'm going to tell you a story. So at the weekend, I was with my little boy, Benjamin, and we had a bag of lollies. We shared them out between us, and there was one left over. Just as I was about to let Benjamin tuck into a lolly, 3 of his friends came along, and we both agreed, luckily Benjamin agreed too, that actually we should put all the lollies back in the bag and share them out between all 5 of us. This time, there were 2 lollies left over. How many lollies might there have been in the bag? So that's our challenge.
So the first part is quite easy, I think. When there were 2 children,
yeah,
Benjamin and one of his friends, and they shared them, there was 1 left over. So there can't have been an even number of lollies, because otherwise there would be. So there must have been an odd number.
Yeah.
Okay.
Now, obviously, Charlie has come to that very quickly because Charlie's mathematics is very sophisticated. In the classroom, depending on the age of the children you work with, that may take some exploration and some more examples. Back
so
to
the
you, Charlie.
next part, you said when there were 5 children, there were 2 left over.
That's right. That's right.
So there must have been a multiple of 5 that were shared out, plus another 2. So 7 or 12 or 17 or 22.
Okay.
Or 27 or 32 or 37 or 42 or 47. Okay. So the units column is always going to be either it's going to be a 2 or a 7. So if you had a very, very, very big bag of sweets, there could have been 102 sweets or 107 sweets.
So might have been.
But if the end number finishes in 2, then it wouldn't have been an odd number of sweets.
Yes, and you're remembering.
So I think there could have been any number of sweets where the units column, the number of units was a 7.
Okay.
So
okay.
47, 77, 107. If you stop worrying about the children's quality of their teeth or something.
Yeah, absolutely.
1007.
Of course, you can change the context of this problem to.
I did suggest.
You did. What did you suggest? Grapes
or apple.
They're quite sweet.
Yes.
Anyway, on the NRICH site, just to help you here, there are some ways into the task that you might like to share with children. There are some starting points, and children could continue this method once they've had a little bit of an exploration themselves. And as I say, Charlie, with his sophisticated mathematics, has come very quickly to the generalized solution. But one of the things we love about this task, obviously, is the fact that it is very much centered on mathematics, the multiples of 2, the multiples of 5, but also that potential for generalization. And I think here, Charlie, the curiosity element in what we've just done here is about having that potential for exploring. There's no obvious way how to do this. I feel like I can be hooked in because I'm not having to remember a method. It's a genuine invitation to explore, and I think that's rather lovely.
But again, you set it within the context of something very real. Yes, if there'd been a different number of children, could all the sweets have been shared out? If, if a 6th child had come, or rather, so instead of 3 other people coming along, if there'd been an extra 2 or an extra 4, is there a way that, or I mean, it's got me thinking. Can I set you a question?
Go on then, set me a question. Am I going to need to write something? Shall I share that?
I didn't do any writing.
Okay, go on then. Challenge me.
But what if at the start, instead of having 2 children, there'd been 4 altogether?
Okay.
They shared them out.
Yeah.
4 children, and there are 2 left over.
Okay.
And then another 2 turn up, so now we've got 6.
6. Yeah.
And when they put them all back in the bag and then share them, this time there are 3 left over. How many sweets might there have been?
Okay, so let me rehearse that. We've got, so when there were 4, there were 2 left over. So I could think of that as a multiple of 4 plus 2. Okay. And then you said when there are 6 children, there are 3 left over. So a multiple of 6 plus 3.
And if you need help, you can ask participants to help you.
I think I might. What I've got up here, actually.
This is like
go on.
The millionaire thing.
I'm phoning a friend.
Phoning a friend.
Yeah. We happen to got the number square on the screen as well, which is quite nice as well. Okay. So in Charlie's example, we've got a multiple of 4 plus 2 number of sweets, but also a multiple of 6 plus 3. Can anybody help me out? How many sweets could there have been in the bag? I'm going to give you a couple of minutes to think about that.
But I'm hoping you're thinking about it as well.
I am thinking about it.
You don't want everybody else to do your work.
Well, I might do, but I'm thinking about it. Yeah. I can think, yeah, I can use this to think about it a bit. A multiple 4 plus 2. Okay. And what I might do is just pop what we've done in the chat, just so we've got a record. So we've got oh gosh, if I could type it would be easier, wouldn't it? A multiple of 4 plus 2 and multiple of 6. Okay, that's what we're trying to find. Okay. I'm not sure Charlie's been particularly kind to me with this example. So we've got David. David has posted his thoughts. If you're happy, if you don't want any spoilers, I would suggest not to look at the chat. I'm
glad that David has found it amusing.
Yes. Ha ha.
Yes.
Brilliant. I can just about see the funny side. Yeah. Yeah. So in the classroom, I think, again, depending on the level at which the children are working, you might expect them to be using perhaps a number square, marking off the possible numbers that would fit each rule, trying to find a number which satisfied both rules at the same time. And if they were working like that, I imagine they'd come to a point where, as a teacher, you might be saying, so has anybody found a solution yet? And there might be a few, well, no, or I think I have, and then we check and we haven't found one. So this is taking a long time to find a solution. There's a lot of us working on this problem. Why can we not find a solution? And as David has pointed out, Charlie has sent us down a bit of a rabbit warren, for want of a better word. So multiples of 4, we know are even. If we've got 2 more than a multiple of 4, that's going to remain an even solution.
So you're going to get numbers like 2, 6, 10, 14,
exactly.
18, 22. It's the even numbers that are not multiples of 4.
Exactly.
Either 2 more or 2 less.
2 more or 2 less.
So 40 is a multiple of 4, 42 isn't.
Right.
So you might get 42.
Right.
Or 46 or 50 and so on.
Okay. Now, if we think about the other criteria, you said 3 more than a multiple of 6. Now, I know, again, all multiples of 6 are even, but if I'm adding a 3, then I'm always going to get an odd number. So on the one hand, I'm looking for an odd number, but on the other hand, I'm looking for an even number. So you've set us up for a problem that actually doesn't have any answers at all. It still has a solution in the sense that we can reason why we cannot find a number of lollies that satisfies these criteria, which is rather nice, I think.
And also asking students to come up with other examples which are going to be impossible.
Absolutely.
And,
yes, absolutely. So we hope that would, I think that idea of, oh, why can't we find a solution? Is there a solution? That's a really lovely hook, I think. And often children don't get the experience in their maths lessons to work on a problem that doesn't have a solution. So this is a very accessible way of doing it.
But even asking students to think of a number, because obviously, to think of a number and give 2 clues.
Yes.
So an answer that is possible, and give it to their friend to work out. And likewise, while they work out the answer to their friends' clues.
Yeah.
There's something about curiosity which is, there is the maths, but it might be that if you and I are working together, you're thinking of, I'm going to make the next problem for Charlie even, hard because he's just tricked me, or I'll think of 71 or something, and I'm going to give Charlie clues. Oh, it's a multiple of 3, and there are 2 left over, and there's a multiple of 10, and one, whatever. And I'm going to be quite intrigued to find the answer to your problem in the same way that you might want to work out, which is slightly different to working out the answer to a question on a sheet or a book.
To a pre-made question. I agree.
When we give each other puzzles, it has a different kind of
different
quality.
Kind of motivation. I agree. Yeah. I agree. Okay, Peter, you mentioned a couple times on the chat the power of Numicon. Absolutely, and we totally agree. Yes, thank you for bringing that to our attention. So let's move on to another problem. Now, this next problem that we're going to have a look at is actually, it takes the mathematics of what we've just been doing with lots of lollies, that sort of step further. So what I'm going to do is I'm going to have a look. This task, as we're going to show it now, is not on the primary mapping document, but it is on the secondary mapping document, but it is extremely appropriate for the very top end of primary, and we will show you a little bit later this afternoon a slightly more accessible version. We wanted to do this one first because the mathematics continues. We are absolutely thrilled to share this with you because this is a brand new interactivity.
You're the first teachers.
It's so exciting. And while there was an interactivity in this problem already, this is sparkly new and even better. So here we have, now, the way this problem works is that Charlie and I have no idea what the solution to the way this is set up now is. We're all working together. Yep. So as we are told, Charlie's Delightful Machine has chosen some rules. So a different rule lights up each light. And we are invited to discover what the rules are that lights up each light. So Charlie, how might we go about this? Well, we can see already, look. 0 is being lit up by yellow and blue. So this is really useful. Okay. So I guess as a student, I might just type in any answer.
I'd rather you were systematic.
Yeah, my instinct is to be quite systematic. So I'm just going to go up. Okay, green 1.
I'm going to make a note on my bit of paper while you're doing this.
Brilliant. 2 is lighting up nothing. 3, nothing. Ooh, red 5. So have we lit up everything once now?
Yes.
That's great. Okay. So I don't think we can do much until a light has been lit up twice.
Yes.
So let's carry on. Nothing. Ooh, 8 lights up blue and green.
Okay. So blue was lit at 0 and at 8.
Okay, I'm going to write this in the chat. So blue was 0 and 8. Yeah.
So if it's going up in 8s, I'd quite like you to try 16 and see whether blue lights up again.
Okay, let's try. So I'm going to type in 16. Ooh.
And let's add another 8, shall we?
Yeah,
24.
Ooh.
So I think we can check our answers.
Okay, let's see. So checking my answers, we think that the blue light, so we're going to fill in this one here. So let's
exactly a multiple of 8.
Multiple of 8. So I'm just going to put multiple of 8. But
we know 0.
Yeah, we know it's 0.
And submit. You get a tick. Good.
Fantastic.
Okay, we've cracked the blue one.
So I'm going to go back because we'd like to crack the others.
We got to 8. Can we go back to 9 now?
Yes,
so that we carry on in the order?
Carry on where we were. What about red? Can we? Oh no, hang on a second. What about green? Haven't we got 2 for green?
Oh, we do have 2 for green. For green, we had 1 and 8.
Okay, so I wonder, what do we think the rule for green might be? It's lighting up 1 and 8. What could it be? Shivangi's suggesting check for 27. I wonder why.
If it's going up regularly like the other one, And Bernadette says it's going up in sevens. I think we should try 15. Because if we had 1, 8, 15, we'd expect.
Nice.
And then another 7 will take us to 22.
22.
And then another 7 will take us to 29. Again, green comes up. So I think we can do the rule for green. It's always one more.
Oh yeah, Peter's helped us there. Thanks, Peter. One more than a multiple of 7. So we think it's one more than a multiple of 7, or we could alternatively describe that, I think, as 6 less than a multiple of 7. Now, we're very aware that the way we have created, brilliant, the way we've created this problem is, as we suggest, much more. We're inviting children to think of these sequences in a very particular way. I think it's much more natural for younger children to think of this as adding 7 or adding 8, but it's really powerful. Charlie, I think from a secondary teacher perspective, an activity like this is really preparing the ground for thinking about linear sequences. If we're thinking about multiples and how more or how much less than a multiple, describing sequences in that way.
But also, all of a sudden I thought, can I get both blue and green to come on at the same time?
Ooh.
And I'm aware that 64 is a multiple of 8.
Yes.
And it's also one more than 63.
Which is a multiple of 7.
So could we type in 64? I think blue and green might come on.
Nice. So these are the kind of questions we might be asking children. What we did want to show you, because I mean, I think the lighting up of the light bulb is the hook here. I think it's delightful. Well, Charlie's delightful machine. But we wanted to show you that if we press on the cog, click on the clog here, the cog, you can see that this is coded like this. And we hope that that makes it fairly self-explanatory. So the first number, so the first 2 numbers refer to the top light, which was the yellow light, I think, if I'm remembering correctly. So that means the first 2 numbers in the sequence for yellow are 0 and 11. So then for red, the first 2 numbers are 5 and 11. So you could input your own code here. You could very deliberately choose sequences that were appropriate for your class. We're so excited by this interactivity.
Yes, and it's very like the lollies, where I gave you 2 more than multiples of 4.
Yes.
So the first 2 numbers would be 2 and 6.
That's right.
So 2, 6 would be the instruction for, and the other one was 3 more than a multiple of 6. So the first 2 numbers would be 3 and 9.
That's right.
And then you could see that you're never going to be able to like both at the same time.
We should just very quickly show you this, because this is rather lovely. It's giving, we're not going to go into the maths at all here, but this is just showing you some different, some possible ways to represent the results you're getting. We're not going to say any more, but please go and have a play.
Yeah, but you might want to encourage your students to do the recording.
The thinking and the recording first. Yeah. So Charlie, I think this is a lovely example of a problem that's hooking you in. The interactive element it sort of piques my curiosity. We've got another task to show you now, which is, again, it's on the primary mapping document. I'm going to go back to the mapping. And this time we're going to choose an activity, it's a game that we've suggested could be suitable at the upper end of primary. It's in the multiplication and division section again, and this time it's in year 6. I'm hoping it is there. Can I see it? Oopsie. Here we go.
Oopsie, this reminds me of Notting Hill.
There we go. Statement snap. Statement snap. So this is a game you could play, I think ideally in the classroom. Maybe I would want to play a pair against another pair. Charlie and I are going to try and demonstrate this for you, but this is definitely one where we're going to need your help. So I'm going to stop sharing the screen and instead go back to the camera. There we go. So what we've got is a pile of cards. Charlie, would you mind? Brilliant. And we're going to turn over 2, and the aim. I mean,
I've been shuffling them while you've been talking.
Do you think I might have placed them carefully? Doesn't trust me at all. We can play this game in all sorts of ways, but we'll just give you the gist and you can tweak the rules. So we're going to turn over 2 cards. And the idea is we're going to try and think of a number which satisfies those two rules. So a triangular number we've got, and at the same time, 1 less than a square number. So, okay, so triangular numbers, Charlie, I think I might want to, yeah, brilliant. I was just going to say, having some little pictures, triangular numbers may not, the actual label triangular number may not be familiar to all year 6s. Thank you to those of you who are already helping us out. So we've got 1, 3, 6, then I believe it will be 15. Ooh, I think, Charlie, a 10.
Add 2, add 3, add 4.
Thank you, thank you. I think already in your picture we've got a number that satisfies that. I think 3 is 1 less than a square number.
Because I could add that.
Yeah. I was getting excited because the next triangular number is 15.
To draw it. 3, 4,
and I happen
5,
to know that 15 is 1 less than 16, which is a square number as well. Thank you to those of you posting in the chat. 5, 4, 2, yeah, that's it. And 1 more. Brilliant. Yeah, happy?
No, I know that 15 is 1 less than 16.
Yes.
I'm just trying to, so I'm going to have to, I don't know, do something like get rid of this one and put it there.
Nice.
Get rid of this one and put it there.
Yeah. And that's showing we're missing the spot here.
We're missing 1.
Lovely. Nice drawing.
Okay.
Nice drawing. Okay, so for those 2 particular cards, we were able to find, well, I wonder how many there are. Okay, let's try 2 more.
2 more. A product of 2 primes
and a square number. Now that's interesting, isn't it?
Okay, so I'm going to make life a bit easier, I'm going to write some primes down here, but I wouldn't do this for children.
Well, I mean, this is an interesting one because a square number, well, I don't know how much to say. I mean, we could leave you participants to make some suggestions here.
And my square numbers look like that.
Mm-hmm. You see, interestingly, I think, Paul, you've just beaten me to it. That's exactly what I was thinking. I was thinking, why not? Can the 2 primes be the same prime? Yes. Surely we can have 3 times 3. 2 times 2. Charlie's looking doubtful.
2 primes feels like they ought to be different.
Okay, all right then. All right. So we could do it very easily if the prime was the same. 2 primes were the same. Has anybody got a solution where the 2 primes are different?
Yeah, I'm not sure it's going to be possible.
Peter thinks it's not possible. Peter, okay.
I don't think
okay. Shall we leave people to think about that, or do we want to flesh that out a bit?
David is still finding it
amusing. I like the fact that we're amusing, David. It's great.
Because we do have a problem called Make 37, which also is impossible.
Yeah.
And it used to upset a lot of teachers, and that they were being asked to do something. And after doing quite a lot of work, they discovered that actually there was no solution. Right. I think we're going to leave people to think about this one.
That's good. I like that.
I don't have a ready. But this talked about a product rather than the sum of 2 prime.
Okay.
So maybe...
Thank you, Neela. Thank you very much, Hannah, for thinking and offering, but we're talking about a product, not a sum.
Good.
Okay, let's move on from there. But there you can see how that's a great starting point. Please don't apologise, Hannah. It's fine.
Let's stop sharing.
Let's stop sharing the page, and we have got just a few minutes left. I wonder whether I'm just wondering what we should do. I think I would really like to show you just really quickly. I'm going to go back to the curriculum map. We're not going to have any time to do this problem, but I'd like to share it with you. Still on the multiplication and division section in the facts at the top. Let me show you Light the Lights again, which is closely connected with Charlie's Delightful Machine, and again has a delightful new interactivity. The difference between this interactive and Charlie's Delightful Machine is that this one, the sequences are all multiples. There are no shifted multiples. So it just makes it a little bit more accessible, but it works in exactly the same way. So please delve into that one. I'm not sure we're going to have time to have a go now. We wanted to flash up 2 activities for you that, again, we're not, sorry, this one was called Light the Lights again. Oh, maybe you were referring to the previous one, Penny. That was called Statement Snap. Oh, I'm so sorry. I'm not sharing the screen. Oh, so sorry, so sorry. It would be extremely helpful. Thank you to those of you pointing that out in the chat. Here we go. This is Light the Lights again. So this is like Charlie's Delightful Machine, but the sequences are all multiples. They're not shifted at all. So it's just a little bit more accessible in terms of mathematics. I would like to share 2 more with you very quickly, but in the meantime, I'm just going to put up for you. We very much actually, I'm not sure that I'm going to have time to share these.
Why don't we go back to the teachers landing page,
yes.
The primary teachers page?
Yes.
Because if we show everybody where to find the curiosity resources,
that'd be an excellent
we've got a guidance sheet, and the guidance sheet has links to, we'll make sure that it's got the guidance, links to all the problems we showed today.
Great idea,
and
Charlie.
All the others that we're recommending.
So I've popped a feedback form link in the chat for you. Please do take a moment to complete that. We really appreciate your feedback. But what Charlie is saying, I think, is a really good plan. Here, if we go to the primary teacher landing page again, we go to our Developing Positive Attitudes, Mathematical Mindsets. Here is the curiosity link that we went to earlier. At the very top of the page, well, first of all, you've got a whole load of tasks here linked according to the rough year group that we think they would be suitable for. There are lots of tasks, so please do explore those, some of which we've tried today. And this is the guidance page. So we've tried to pull out some of these points as we've been talking this afternoon, but do have a little read, different ways of nurturing students' curiosity. In each of these sections, as you can see, we've linked to a number of different tasks at the range of age groups. And
there's a link there I can see. Charlie's Delightful Machine.
Yes, and lots of lollies is one of them.
And we'll make sure that that's up to date.
We'll make sure that we've added links to everything we've tried today. If you are using this with colleagues, there are some questions you might like to consider, and also there is some follow-up reading material which you might like to look at again.
And by the end of the week, there will be a link to the webinar. So
yes,
if anybody at your school hasn't been able to attend today and would like to, or you would like to present some of the ideas from today, the webinar will be uploaded later in the week.
The recording will be right at the top of this page, the Nurturing Students' Curiosity page. We're sorry to have, galloped towards the end there, but we do hope that this has been useful, that you've got some ideas to tap into students' curiosity. We thank you very much for participating. It makes our lives a lot easier. And please do complete the evaluation form. It helps us give feedback to our funders as well.
I'm just wondering, and I know we're sort of saying goodbye, and please do
if you need to go. Yeah.
Do complete the feedback. But I think just to finish off, just for those of you who've never seen it before, I'd quite like, and there's no obligation to stay for this. This is like break time, but it's raining outside. You might want to stay in the classroom. Let's do number jumbler with everybody, just to give you a flavour of one other problem that we think is rather wonderful.
The reason we haven't taken more time on this one is because we've used it in lots of our webinars before. So if you wanted an in-depth exploration, do go and look at the recordings of previous webinars. But this is, as Charlie said, this is a rather lovely task. So Charlie, what we're invited to do here is to choose any 2-digit number.
Okay. So I'll choose, so it could be 42, 75, 18, 81.
Yeah.
The 2 digits could be the same. It could be 44, 66. Okay, I'll choose 42.
Okay, and then add those digits together.
So in my case, I would add 4 and 2. So we'd like everybody else to choose. Can you please choose your own 2-digit number and add the 2 digits together?
Yep.
Okay.
And then you need to subtract that total from your original number. So in your case, you're taking 6 from 42.
I will take 6 away from 42. Okay. And we'll give everybody 10 seconds to do the calculation.
And then you need to find that resulting number on our chart here and focus on the image which is just to the right of it.
So you may be, if you end up with 55, you might be looking at a bicycle image. If you end up with 17, you might be looking at a star.
Yeah.
If you finish with 20, you might be looking at a pair of cherries.
Right.
Okay.
So what we're going to do is we're going to click on the machine. It's going to take all the symbols and jumble them up, hence being called the
I was looking at something that looked a bit like a brain, I think.
Okay. Okay.
Oh, wow.
Ooh.
That's what I was looking at.
How about everybody else? I wonder what symbol everybody else was. Oh, Paul's same. Okay. A couple of people have the same. Oh, Laura. Oh, a lot of people are saying they have the same. Interesting.
That's reassuring.
That is reassuring. So I mean, immediately, if I was a student, I'd not seen this before, I would be, I mean, that is going to make me curious.
Yeah. How then? How did the computer know?
How did the computer know? So if you've not explored the task,
it's called Number Jumbler.
Number Jumbler, please do it. And it is linked from the Curiosity guidance, this one.
Okay, so sorry to keep you. There is one question that has been asked, which we think should be responded again. Somebody's been looking for the recordings of the session.
Of the previous webinars. Okay, so probably the easiest way to find the recordings is to go to our Problem Solving Schools menu, click on the Resources and Professional Development link at the bottom. And we mentioned at the beginning of the webinar that we've done webinars on each of these 5 mathematical thinking themes already. So if I click on any of these, what I will find is links to the recordings right at the top of that guidance. So for example, clicking here takes me to the recording. So on any of those 5 mathematical thinking. And what you will find by the end of this week is that clicking on the Being Curious link will take you, it already takes you to the guidance, and we will put today's recording there. So that's probably the easiest way to find them. Yeah, so we hope that helps. We genuinely have run out of time. Thank you for staying with us.
It's not raining outside, so you can go out into the playground.
We hope you have a good rest of the day, and we look forward to seeing you again at a future webinar. We should have looked up the dates. It's fairly early May.
If you go to the primary teachers page, and click on events.
Or if I click events in the teachers menu, it should tell us that's today, 6th and 7th of May. So for primary teachers, we're looking at nurturing resourceful problem solvers on Tuesday, the 6th of May. So
and then in June, we're going to be looking at resilience.
Details will be available to sign up fairly soon. Thank you so much, all of you. Have a lovely rest of the day.
Enjoy. Bye.